In this course, I will introduce you some of the new features of positioning control for MPLC. I will walk you through some noteworthy new positioning control features then, including Function 140 HSBSO S-curve, Function 137 ICA, Function 138 ICF, and Function 144 HSBWM2. Please be noted that we will be using the MPLC programming tool, UpperLogic, at version 0.11.5. You could obtain the latest version of UpperLogic by accessing the FATEC official website. For MPLC, the maximum supported axis number is 8 at 200 kHz. Both S and T curve acceleration are provided for point-to-point control, and linear as well circular interpolation will be coming soon. Function 140 now supports S-curve. Originally, only T-curve is supported, which gives a sharp change of speed when reaching target speed. On the other hand, S-curve operates with more of a smooth change of speed, which allows a more stable way of control, possibly causes less damage to the machine in the long run, yet with sacrifice of speed of action. Function 140 behaves the same way for both FBs and MPLC. The only difference for now is the addition of S-curve. Regarding the setting of S-curve, 50% means S and T-curve takes half and half of the acceleration individually, the percentage of which depends on the application per se. When S-curve is configured as 0%, it works the same as a T-curve. MPLC supports up to 8 axes at 200 kHz for positioning control. In this example, 2 steps basically share the same settings, except that the first step uses T-curve and the second step uses S-curve. We can observe the change of speed from the right side coordinate graph of time and speed, which clearly demonstrates how smooth of a S-curve is in comparison to a T-curve. Now that we know about the S-curve, let's make some curves, shall we? Create a new project. Add a function 140 and fill in proper parameters. Set the pulse output type in I/O configuration. Select and press Z on the function 140 to set up a servo program table. Set up the table according to the example shown. The first step uses T-curve, and the second step uses S-curve of 100%. Download the project to the PLC. Change connection mode as online monitoring or online editing mode. Here we use real-time data chart to observe and compare between T-curve and S-curve. By adding our 35328 of PSO0 speed and our 35336 of PSO0 current position to the monitoring list, after starting the process of monitoring, we can now run the PLC and enable the function 140 to proceed with the observation. Function 137 ICA stands for interrupt constant angle. After enabling a function 137 on a given axis, the axis will rotate towards a given direction at a given constant speed, and then stops at a given angle when a specified interrupt source is triggered. The definition of function 137. PS is the axis index. LS specifies the interrupt source. FO is the constant speed. AG is the angle to stop it after LS is triggered, ranging from 0 to 360 degrees. The direction can be specified through input D/R. The video demonstration of function 137. Like function 140, function 137 operates on the settings of an axis from function 141. X0 is the interrupt source. Constant speed is 10,000 Hz. Stop angle is 90 degrees. The down right clip shows that when X0 is lit up, the axis starts the angling process and eventually stops right at 90 degrees. Function 138 ICF stands for interrupt constant feed. After enabling a FUN 138 on a given axis, the axis will rotate towards a given direction at a given constant speed, and then stops after moving for a given distance when a specified interrupt source is triggered. The definition of function 138. PS is the axis index. LS specifies the interrupt source. FO is the constant speed. FD is the distance to move after LS is triggered. The direction can be specified through input doctor. The definition of function 138. PS is the axis index. LS specifies the interrupt source. FO is the constant speed. FD is the distance to move after LS is triggered. The direction can be specified through input doctor. Like function 140, function 138 operates on the settings of an axis from function 141. X0 is the interrupt source. Constant speed is 10,000 Hz. Stop feed is 32,768 pulses. The down right clip shows that when X0 is lit up, the interrupt program of X0 records current position of the axis as 32668, and then the axis starts the stopping process and eventually stops right after 32,768 pulses, resulting in the current position at 65436, from which we can subtract 32,668 and get 32768. Function 144 HSBWM2 is an improved alternative to function 139, without the use of formula and being able to accept PWM frequency directly. Function 144 HSBWM2 also supports dynamic change of speed on the go. The definition of function 144. PW is the axis index. OP specifies the polarity of the PWM. Hertz is the PWM speed from 0 to 200 kHz, or determines the width of the PWM pulse. The video demonstration of function 144. First, configure the output setup of PSO0 as pulse for Y0. Here we want to output a PWM at 8,250 Hz. but the closest frequency that function 139 can achieve is 8,777 Hz, whereas function 144 is easier to set up and provides a more accurate one. The downright clip shows the PWM frequency captured using an oscilloscope. Please feel free to ask any question or make any suggestion to the local FATEC distributors worldwide, or leave a message on the website.